right, Mathletes. Today we are on session 7 of our training camp, and today's the day that we're going to take all of the addition and subtraction models that we've been working on and we're going to mix them together. So I'm going to show you 3 problems today, and today's going to look a little different because after I present a problem to you, I'm going to ask you to pause and think about what type of problem I'm showing you, whether it is a part-whole problem or a comparison problem, or if it is a change problem. Then I'm going to reveal what problem type it is. After doing that, I'm going to ask your teacher to pause the video and I'm going to have you work the problem out on your own. After you do that, we're going to resume the video and see if your answer matches mine. And we're going to do that for 3 problems today. So let's go ahead and get started. Remember, the whole purpose for doing what we've been doing is so that we can solve those word problems on our grade level. And today's the day that we see how much information you're retaining about the addition and subtraction models before you move into the multiplication and division. So let's take a look at this first problem. Think about which model you would draw to solve it. Ron sold 5 boxes of milk chocolate almonds, several boxes of mint chocolate, and 4 boxes of dark chocolate. He sold 17 boxes total. How many boxes of mint chocolate did he sell? So let's think about this. Are we putting numbers together or taking them apart? Are we putting numbers together and then reversing and changing our action and taking them apart? Or are we comparing one number to another number? All right, tell me. This is a part-whole problem because in this problem, we are either putting numbers together or taking them apart. There's no opposite or change in what's happening, and we're not comparing more than or less than of something. Okay, so now that we see that it is a part-whole problem, I want you to think about how many parts we need. Let's see, we're talking about boxes total. So we know that we're talking about boxes. And we're talking about chocolate, right? So take a look and see if you can tell how many different types of chocolate are being sold. Okay, I think you know how many parts it is. Teachers, if you'll pause the video and allow them to solve, please, and then we'll resume in just a moment. Okay, so take a look and see how you did. We had 3 boxes. We have our milk chocolate, we have our mint chocolate, and then we have our dark chocolate for a total of 17 boxes. So let's see if this is how you filled your model in. We had 5 milk chocolate, several mint chocolate. Remember, if we say several, we don't know what that number is, but we know it's a number. So that's our unknown. And then we have 4 boxes of dark chocolate for a total of 17 boxes. So in order to solve this problem, I hope you remembered that we take those parts that we know, 5 and 4, and combine them. And we know that 5 and 4 make 9. So now we can go to that 17 and we can pull 9 from it. And when we pull 9 from it, how many boxes of chocolate are left from those 17? 17 minus 9 equals 8. So our unknown would be 8. How many boxes of mint chocolate did he sell? He sold 8 boxes of mint chocolate. Problem 2. Remember, think about which model this one can be. Listen for part-whole language. Listen for changing and moving to a different operation. And listen for comparing. Here we go. Mark is 7 years older than his brother, John. If you add their ages together, it would equal 23. How old is Mark? So let's think. What kind of problem are we seeing here? Part-whole, change, or comparison? Think and tell me. I hope that you said that this is a comparison problem, because we see that comparing language there about Mark being older than his brother John. So we're comparing older than, we're comparing Mark to John. So in that, we're going to need to be comparing Mark's age to John's age. All right, this is not an easy problem. This is the hardest one today probably, so I want you to really think about it. Plug those numbers in as you read, and then try and solve. Teachers, pause please. Okay, let's see how we did. Let's compare yours to mine. So I've got Mark on top, a top box there, because I read about Mark first. So I'm going to plot his information first. And then I've got John in that bottom box. Now I see that Mark is 7 years older than John, which lets me know right away that I'm going to need to give Mark that longer box. Mark's going to need a bigger box. I also know, and the reason why I've got two different boxes for Mark, is I also know that I'm going to be looking for that information that Mark and John have in common, and then I'm looking for that extra years older that Mark is. And it tells me here that Mark is 7 years older, so I know right away in that extra box that Mark has that John doesn't have is 7, because he's got 7 extra years on his brother John. I also see that if I add their ages together, it would be 23. So I put that 23 out here to show that if I put all of these numbers together, Mark's part and John's part would equal 23 if I put them together. Now, how do I solve this? I'm looking for what Mark and John have in common. So to solve this, the first thing I need to do is pull out that information that Mark has that John doesn't have. So 23, if I'm going to pull out 7, 23 minus 7 gives me 14. So I know that if I pull out, 23 minus 7 gives me 16. If I pull out that 7 and I have 16 left, that 16 tells me what Mark and John have in common together, right? So if they have 16 in common, if these two boxes add up to 16 and they've got to be equal, I need to take that 16 and I need to split it apart into those two equal boxes, giving me 8 and 8. So all of these numbers will add up to 23. And the question is, how old is Mark? So what do we need to do to figure out how old Mark is? I need to put together 8 and 7. 8 plus 7 equals 15. And let me tell you, those of you that are third graders watching this problem is more than 2 steps, which makes it actually an above level problem for you. So if you found this one to be challenging, it should have been challenging. Okay, let's go ahead and look. We have one more problem. Which model? Listen very carefully for what is happening. Ariel collected 17 Mardi Gras beads at her first parade. So she's collecting. So this is how much she has, right? She collected many more at her second parade. But then she lost 5 pairs of beads on her walk home. Now she has 20 pairs. How many did she collect at her second parade? Think about what's happening in this problem. Are we putting numbers together or taking them apart? That would be part whole. Change, are we putting them together and taking them apart? Are we changing our actions in the same problem? Or are we comparing more than, less than, longer than, shorter than? Ready? What model would you use? Think and tell me. This would be a change model. This again is the most challenging change model problem, and I gave you a challenging one on purpose. I want you to really think through the problem and don't stress yourself out if you have trouble solving this one. Teachers, go ahead and pause the video and let's see what they can do. All right, let's check and see how you guys did on this one. Again, this one was tough. I went ahead and drew my lines because I know that each of these have 2 parts. And I'm going to go ahead and read. Ariel collected 17 at her first parade. So I've got my 17. I don't know yet where it belongs in my first box. I don't know if it's my part or my whole because I need to read my next sentence to find out. She collected even more at her second parade. Oh, wait. So she collected many more at her second parade. So that means I'm going to put together what the 17 that she had in her first parade plus even more that she got in her second parade. But then she lost 5. Uh-oh. I can't show that I'm pulling 5 out on this model. So I'm now taking numbers apart, so I need to change to a second model. Now, before I can do that though, I'm missing some information in my first model, and I can't solve it yet. So I'm going to put a question mark there. And whatever belongs there where that question mark is, I'm going to need that to solve the second part of my model. And so remember, I'm going to carry that information over even though I don't know what it is yet. And now I can show that she lost, whatever that amount is, she lost 5 pairs. And now she has 20. How many did she collect at her second parade? Remember, this is the big question we're trying to find out the answer to. But in order to do that, first I've got other information I need to solve. And I can do that now. Because look, I know I take parts together to make a whole, don't I? So 5 plus 20 gives me 25. So I can take that and now I can go ahead and put that together. 5 and 20 gives me 25. And if I know that this question mark actually means 25, I can come over here and plug it in here too. And now that I know this means 25, if I'm missing a part, I just need to subtract. So 25 minus 17 gives me 8. So N actually equals 8. How many did she collect at her second parade? 8 pairs of beads. Boy, that one was tricky, very challenging. I purposely gave you the hardest version of each model so you could really think through it. And what you're going to be doing today, instead of an exit ticket, you're not going to be doing it your normal exit ticket. You're going to be doing the post-test of the addition and subtraction unit to see how you do. I think it's 4 problems. Your teachers may have to double check that. And teachers, again, you can have that done today, or if you choose to do that next week, that's fine as well. Just make sure you review these models before giving this test. And guys, do your very best work on this because this is where we see how much you've grown with using these models. All right? Have a fantastic day.